Alright guys, it's time for the final hurdle before we get to our goalpost. In this lesson, I want you to switch over to the final hurdle challenge, which is hurdle 4. And in this particular version of the hurdle, the wall that the robot has to jump over to now has a variable height. So the height of each of these hurdles is completely random, the position of the hurdles are random, and also the number of hurdles is also going to be random. You can see that every single time that this regenerates, it comes up with a completely different set of hurdle profiles. And now we can't just jump because we don't know what the height will be each time. So we have to use what we've learned about while loops to modify this jump function and see if we can get the jump to jump as high as necessary depending on the height of these walls. Just as a reminder, in order to complete this challenge, you should take a look at the Rebor's keyboard window and go to this tab called Conditions and see that you can check if the front of the robot is clear, if its right is clear, if there's a wall on the front, if there's a wall on the right, and various other things. The ones that are probably going to be the most useful is this top row here. So we want you to take a look at these conditions, see how they're spelt and how you can use them, and then try to use them and test them out using your Reborg robot. Now the goal is of course to reach this final flag, going over various hurdles using this dotted line as the path, which is going to be different each time. Just as a head up, this is going to require you to modify this jump function, have a serious think about it because it's not easy, and you're going to need to use more while loops to achieve this end outcome, and try to see if you can solve this challenge in the least lines of code possible. So I managed to do it in as little as 24 lines of code, so see if you can aim to achieve that. Pause the video now and give this challenge a go. Alright, so the key difference between this particular hurdle and the previous version is that the height of the wall is now random. Instead of just jumping over one square where we turn left, move, turn right, move, we have to now see if the right side has a wall or if it's completely clear. Now, in this case, what I want to happen is I want to turn my robot to the left first of all, and then I want to check if there is a wall on the right. So I can use this condition, wall on right, to achieve this. And if that is true, then I want to continue moving forwards until there is no longer a wall on the right, in which case I'm going to turn right, and then start going down. So let's modify this jump function. We definitely need the robot to turn left, but after it turns left, we're going to use a while loop to say that while there is a wall on the right, then in this case, we're going to move forwards. So we're going to go up in this direction basically because we've turned left already. Let's test this out and let's run this code. You can see in this version of events, my robot is going to keep going until the very end of the screen. This is not what we want. So what we want to do is when this is no longer true, it's going to skip to line 10. So at this point, there is no longer a wall on the right, because otherwise it would have continued looping and calling this line 9 where it gets it to move forwards. When there's no longer a wall on the right, then we want to do what we did previously, which is to get our robot to turn right, move, and then turn right. Now at this point, we have to move down the wall, and what we're going to check is whether if the front is clear, because it's only when we reach the very bottom here, when the front is blocked, do we actually turn left again and continue back to our while loop here to move forwards. To do this, we're going to add yet another while loop, and in this case, we're going to use the front is clear condition. While the front is clear, we're going to get the robot to continue moving forwards. So once it's turned to face this direction and there's no wall in front, it's going to keep going until this is no longer true. And that is the end of our jump. So now we've basically modified this jump function to take into account all of these new things, such as while there's a wall on the right, then continue moving upwards. While the front is clear when it's coming down, then continue moving downwards. And then at the very end, we're going to get our robot to turn left, so that we're ready to go and check if we're at the goal. And if we're not at the goal, then we're going to check if there's a wall in front. If there is a wall in front, then we're going to jump. Otherwise, we're going to continue moving forwards, or rather to the right, to get to the goal. So now this is the final code. And depending on the number of spaces you've added in here, obviously it's a little bit easier to read if you actually have it like this. But depending on how you've spaced things out in your code, you should end up with anywhere between, say, 20 to 24 lines of code. So I want you to be able to see all of these lines of code on the right when we run this code. And I've actually got a typo in here that it's going to tell me. So it's going to say invalid syntax, and the problem is just because I forgot a colon here. If you get that pop-up invalid syntax, be sure to check if you have any problems in here. And it can get a little bit complicated if you leave your code for a long period of time before you test it. So test your code after every little iteration, and then when you actually get something like an invalid syntax, you'll be able to catch it more easily. So now let's go ahead and regenerate our map, and let's try again. So when we're going to make a jump, and then we're going to turn right, and we're going to keep going down until we hit the wall or we turn left. And now we're not at the goal and there's still a wall in front, so we make another jump and we go down this much, much larger wall. And then we continue this process of using several while loops, checking if there's a wall on the right, checking if the front is clear, checking if there's a wall in the front, in order to achieve our goal and get to our final destination. Now, for your code to successfully complete this challenge, the line that your robot draws should follow the line that's dotted here, just like what you see here. So instead of going just over the top and getting to the final goal, it should follow each of these steps, and finally you should get that green pop-up where it says it's at the right position. So did you manage to complete this challenge? If not, be sure to review the lesson on while loops and just have a play around with while loops. Try some of the different conditions and see what happens when you run the code and see how the robot behaves, so that you get a good grasp of how these things actually work. Now, on the next lesson is our final project, and we're going to get our robot to be able to navigate a maze all by itself using what we've learned, including functions as well as while loops, as well as using good indentation. So for all of that and more, I'll see you on the next lesson.